Hello everyone, I'm again. Okay, in this lesson, we will record some code related to the client. Okay, our server side is already fully written, so we don't need to touch it. So for the client side, let's first define the client's information. Similarly, on the client side here, we are using WebSocket. Note that these two are different. You can see they are different. Then it's actually the same as what we covered in the previous two chapters. We prepare a client connection here. Similarly, we have the corresponding constructor. Because on the client side, it doesn't just use pointers. It chooses smart pointers. So we have to write it like this. Then here, it uses a destructor. So let's fill in the brackets here first. Here it is. Here, we will take the other constructors and delete them. Also delete these overloaded functions. Do not allow it to do this. Next, we will add a few methods. Similarly, we also need this set method. And this update, this is the header file. We included because we need to use the information defined in our communication. So we have a header file here. These methods are for sending information. Then update our interval time. This is to determine whether it has timed out. This is tick. Then the heuristic here might be slightly off. Let's first extract all these variables. This is what our Wevo gave us, such a smart pointer. And this is our collection ID. Okay, and this is our current. The state of the client connection. These states of the client connection are actually very similar to the server side. And here we have this initial time. The difference is we have a heartbeat time here. So we set the heartbeat time to 3 seconds here. This is our cumulative time. This is our check time. Okay, then you can compare. Actually, these two are similar. But our client side needs to send from the heartbeat. So that's how it is. So we know how to write this. We'll still go through it step by step from the top. Okay, we'll just create it directly. Okay. We put it in the constructor. We perform a simple initialization of this variable. First, we let the which icon it holds, such a smart pointer as null. Then pass the client ID from the constructor into it. Set the remaining two states and the server's connection ID to null. Then, when we pass it for initialization, we can do it via GUID. We can also do it by directly passing a agent. The difference with which agent is that we can make this. We need to hold this agent, such a smart pointer object. Then here, we can let this ClientCollectionID self-construct a new one. Then if we need to handle a situation like copying, we can do it here. That is, when copying, it should be moved. We can see, in this place, we will just copy these things directly. Because we are using smart pointers, there will be no shallow copy, because they all hold the same object. Then the original object can be released smoothly. Okay, when we destruct, we need to handle this WebSocket. First, if this WebSocket is in a connected state, or if it is available, we will close it. And in any case, we will set it to null. Then here we need to include the header file. We'll put this header file here. Okay, good. It no longer shows red here. Let's look at how our data is sent. First, our widget. It must be that when we want to send this data, this socket must be connected. That is, it must be available, and it must be in a connected state. Then we take our message and directly convert it to JSON. Then we use our common YouTube method to encrypt it into binary data. Then we just send it over directly. This last parameter can actually be ignored. Yeah. Because, as we said, what we are sending is actually a base 60页 encrypted string. So we fill in a false here. Sometimes this may have some impact. Okay, then here, when we actually send the heartbeat, this method is to refresh our accumulated heartbeat time. Then how do we determine? Is it timing out? If it exceeds our 10 seconds, our client side and server side, we both consider it as 10 seconds. then we will let it be considered as timed out, okay? The key point is that the tick is different. Then, for the tick, we first check our current time. Check if our current accumulated time has timed out, because our timeout is 10 seconds. Next is the heartbeat time. Determine whether we need to send a heartbeat. So if our heartbeat time is greater than the hash check time, we will set it to 3 seconds. It's equivalent to us doing a heartbeat every 3 seconds. If it hasn't been set within 10 seconds and a heartbeat is received, then we consider it timed out. Okay, then here, if it's time to send a heartbeat, we set this heartbeat time to 0. Then we need to prepare a tick message that we want to send. We just need to copy this code and action. Because the other fields are the same, we don't need them. We don't need it, actually, because it's empty. Then next, we need to copy the other fields. And because these two fields are the fields of this object, after it enters the init stage, this is initial, created by us through the constructor. It must enter our communication after the init stage for this value to have a value. Okay, once it has a value, next we add a description for it. Then we take this data. We don't need to pass the data. We'll place it here because we are using our own new tick. Then we send this data out. Okay, so in this way we have written the information defined by this client, and now we have built it. Good, this is the information defined by our client, and the link has been written. Everyone can take it's still quite simple because the two things are actually very consistent. The only additional difference is that we will let the client actively reach the heartbeat time, send it to the server to determine this, whether it is still alive. Such a state, everyone can take another look. Okay,